Hello, my name's Evie. I make Portal 2 maps. I'm currently making Portal Who, Science of the TARDIS. Maybe you saw our trailer earlier this year. Happy Doctor Who Day, belatedly. I thought to celebrate I might make a little behind the scenes video showing how that materialisation effect works, and a bit of the thought process that went into it. This is not a tutorial, anything you do learn is purely unintentional, and since I'm making this in retrospect, I've recreated some of this for the purposes of explanation. It's not really a perfect recreation of the exact process by which I thought of this stuff, and it smooths out a lot of the trial and error, emphasis on error, that really goes into a project like this. But I hope you find this interesting, and I hope you're excited to play the map itself when we eventually finish it. A bit more on that later. The way this effect works, in 2 words, is material proxies. In more words, every material in the source engine has a text file called a VMT that defines how it looks. And within that text file you can define all sorts of things. You can give it a texture, you can give it a normal map, you can give it reflections, you can even give it footstep sounds. But you can also write little bits of code in those material files, and those bits of code are material proxies. So you'll have definitely seen this if you've ever seen an animated texture or a scrolling texture, or if you're in Portal 2, a fizzler. Because the fizzler has a little power-up animation that it plays when it turns on, and the same animation in reverse when it shuts down. And that's a specialised material proxy. Now, if you ever tried applying a fizzler material to a brush entity that isn't a trigger portal cleanser, you'll notice that power-up animation doesn't actually play. And that's because the material proxy mainly just interacts with the game's code, so that's hard-coded. But did you know you can actually do it manually? Now there's a pretty niche entity in Hammer called a material modify control, and when you place it in game and parent it to a brush or model that uses a material, specifying that material and specify a variable for it to control, you can use certain inputs to modify that variable. In the case of fizzlers, the variable in question is called power up, and in order to play the power up animation, you send it an input called start float lerp, which starts linearly interpolating a float, and you give it a parameter which takes the form of 4 numbers which define the start value, end value, time taken, and whether or not you want it to loop. So in this case it'd be, to power up you do 0, 1, 1, 0, because you're going from 0 to 1 in 1 second and you're not looping. It doesn't have to be between 0 and 1. If it was, for example, frames of an animation, it might go from 0 to 24, it might go from 312 to 5,000,003, but in this case it's 0 to 1. In my case, for the TARDIS, I tend to do 0 to 100 and then divide it down, just because I had some issues where it wouldn't really like going between 0 and 1 for a user-defined variable. Don't know why that was, but my solution did work. As with everything in the source engine, there are about 1 million ways this can go wrong. There are some slight little pitfalls. So for example, if you have the same material on 2 models or 2 brushes, one is handled by a material modify control or handled in code, but if the other one isn't handled, it might still take the values from the ones that are handled. So if for whatever reason you do have 2 instances of the same material, one that is playing some animation or doing something interesting and the other one that isn't, you're still probably going to want a material modify control on both of them, just so that they are isolated and under your control. And a mistake I make every time I do this is I will set up the variable in the material, set up the material modify control in Hammer, try and get it to work, it won't work, and that's because I didn't add the material modify proxy to the material. So in the case of the fizzler, I actually had to duplicate the material, add that little 1 line, and then replace it on the brushes in question. Now, the reason all of this is relevant to the TARDIS is that you don't just have to use the material modify control to access power up, you can use it to access any variable you like, in any material you like, in any material proxy you like. So I defined a variable called fade factor, which I just used mainly to control the transparency of the TARDIS model, but sometimes a few other effects as well. And that means fading the TARDIS in and out is as simple as sending 1 start float lerp input. Or is it? Because now that we have a translucent TARDIS, you can see through it. Oh no. And you can see the problem with that immediately. Even without the police box innards, you can still see through the model to the kind of back faces in all the concave areas. And that's because this is a 3D model and not a 2D image. Seeing all of this is really bad. It makes it look very fake. It makes it look very video gamey. So we need to do something about this. First move is a good thing to do anyway for optimization, but it's to make a simplified version of the model that can just be used for while the model is fading in and out. So it doesn't have all the indented panels, it doesn't have a fully modelled sign, it doesn't have little details like the door handle and the keyhole, it doesn't have window frames, it just has the general shape and the things that really affect the silhouette. Using Substance Designer, I bake the textures onto it from the main model so it lines up perfectly. I just have it at a slightly lower resolution because it doesn't need to be that high resolution, can save a bit of memory there. And when I put it in game, you can see it matches up really well already. It's still not perfect though. even without things like indented panels and all the extra details, it is still a slightly concave model, and I can't really simplify it any further because that would affect the silhouette and it would make the model change really obvious. So I've got to be a bit clever. Since I've already baked a bunch of textures for this, I can use a levels node in Designer to clamp the ambient occlusion bake and basically mask out all the concave edges of the simplified model. I could also use something like a curvature for this, but the AO gives it a more gradual change. It's not so harsh. The effect of this is, in all the concave areas, the model is now transparent anyway, which means the cutoff isn't so harsh, so it no longer looks so fake and video gamey, which is the whole goal. As a nice little bonus to this, if you fade in the solid version over this version with the edges faded out, you get this lovely little filling in solidifying effect, which will be really useful for making the TARDIS feel like it's appearing and materialising in physical space. One of the most prominent stylistic effects that I wanted to recreate for this project was the edge highlight that you get on the TARDIS. Particularly in the 13th Doctor's run, it's more of a refractive glass shimmering effect, which I first noticed in the Ghost Monument, where they had a big fanfare around the TARDIS departing because it's the first time it's happened in this era. And it is absolutely gorgeous, I'm obsessed with it. The best thing about it though is that it's well suited to being recreated in the Source Engine, because the Source Engine, for absolutely years, has had a refract shader. So I made a second skin for the simplified TARDIS model, I applied a refractive material to it, and I had a look at it in game. And it looks really good. The only problem being that it looks terrible. Now obviously I could tone it down, I could make it more subtle, I could make it a different colour, but the real problem with this is that the refract shader doesn't support transparency, which means that my nice trick with material proxies to fade it out apparently isn't going to work. So what I worked out after quite a lot of experimentation is that while you definitely can't control transparency, you can control the refract tint, so the colour that the effect is tinted after everything. So if you set the refract tint to black, then numerically you've set it to 0, and if you then use additive blending, which the refract shader does support, so instead of the refract effect refracting the whole scene behind it, it does that and then it's added on top of the original scene, then you're basically adding 0 to the scene, so you're adding nothing, so it's invisible. So if you fade the colour down from your main colour, or pure white, to pure black, that is exactly the same as fading it from fully opaque to completely transparent. We're in business. I added a few bits of polish on top of this. The fade factor doesn't just control the refract tint, it also controls the refract amount and the magnification, but that's really the core of how the effect works. So the next thing was animation. It's time to get this thing moving. For any timing sequence this complicated, I always like to do it in VScript rather than with Hammer logic, because when you use VScript and you make some small change to the timing, you don't have to recompile the whole map, you just have to reload the map in game. This makes it a lot easier to iterate and to try new things and to use trial and error. The other thing I did was find a sound effect first, so I could build the whole timing around that and I wouldn't have to retime things later. The sound effect is so iconic and it is so unchanged through time, I felt this made sense in this case. Now, I don't have footage of my first attempt at this because it looked bad and I abandoned it pretty much immediately, but I basically tried to create an in and an out function with VScript and then just kind of played those in sequence. The reason this looked bad was it was very robotic, there was no sense of progression, each blink was just completely isolated. It was more like, 5 separate blinks that arbitrarily end on the 5th rather than one progressive fade in. So I did try something like having each fade up slightly more than the last one, but even that, they felt too isolated. So I decided to leverage the fact that I had all these multiple skins for the TARDIS already. I had the solid one, I had the one with the faded edges, I had the refractive one. So to give it that sense of progression, I have the edge faded skin just appear gradually throughout the whole duration of the sound effect. And then for each blink, I simply use the refract effect and the lamp sprite, I have those flash. And then right near the end of the effect, just for the last second or so, I have the solid skin fade in on top of it. It kind of creates this solidifying, finalizing effect. The other reason I didn't want to use it throughout the rest of the effect is you would have that issue with seeing through it to its back faces, whereas if you wait until the effect is almost complete, you're less likely to notice it. And that's really the main thing here. It's not perfect, it doesn't have to be perfect, it just has to look about right and disguise the bits where it doesn't quite work. So now the animation is over, we need to transition back to the actual model that can play animations and, stand up to scrutiny. The name of the game here is just disguising the transition. First and most obvious thing I did is just right at the end I have the refractive shell fade up, I transition there, and I have it fade out again. So then it doesn't hide the transition, but it makes it look more diegetic, more intentional. It makes it look less like a kind of video gamey thing. I could leave it there, but I noticed that with the simplified model, the main problem with it is the windows and the light up sign on the roof are quite far offset from their original position, and since they glow in a darkish environment or just kind of generally they catch the eye more, so the transition is more obvious because they obviously change position. So the solution to this is to export a model that is just the windows and sign, and then for the solid and edge faded skins for the simplified model, I just cut the windows and sign out of the transparency mask so you can see through them. I didn't have to modify the model or anything, that would have been unnecessary, and it would have affected the refract shader, which I did want to keep the windows for. Including that in the effect, I just have it match the edge faded model, so it just looks like one cohesive thing. Another note, materials that glow don't support transparency, so the workaround there is to use a shader called Unlit Generic, which just doesn't have lighting, which means it appears at full brightness in any lighting condition. And with this, I think I'm finished. The difference with that model transition is night and day, and you know, it's not perfect. If you go looking for issues, you will find them, but I think I've disguised them well enough that for most first-time players who haven't seen this YouTube video, it'll hold up. So that pretty much sums up how the effect that you will have seen in the trailer looks, but I have made a little improvement since then. So for the lamp, it's got a sprite on it that suggests that it's flashing, but it would also be nice if it cast light on the scene. And the problem with this is the source engine really doesn't do dynamic lighting. You can give a light entity a name and you can make it turn on, but by doing that, it makes it look much worse. It doesn't bounce the light, and there's a few other problems with it. Generally, you just want to keep your light static if you can. For the trailer, I do have a named light. It's not very obvious there, but it's quite choppy when it fades in, and it doesn't fade in time because timing it is a fool's errand. It just doesn't work. So what I did was just have it start fading in about halfway through the effect, so that then by the time it's faded in, it's at full brightness, and hopefully you didn't even notice it happening. That was the best I could hope for. But see, there's this one shot in Eve of the Daleks where they run out of the TARDIS, and it's materialised indoors, and it's casting light on the low ceiling, and it is beautiful. You can see distortion from the glass, you can see the shadow from the little enclosure, and I just kept looking at it. And what it really said to me was, projected textures. So projected textures are the best workaround for dynamic lighting in the source engine. They're not lighting, they are projected textures, but they do cast shadows, and those shadows can move, so you can use them to simulate lighting. So in Substance Designer again, I made a custom flashlight texture to simulate the distortion and the shadow that I like so much. And then, for very silly reasons to do with the way that projected texture fading in works, and the way that it's really not designed to work in the way that I'm trying to use it, it was necessary to have 6 projected textures, each with a different brightness, and they get faded in and faded out and enabled and disabled in sequence, because that's the other thing about projected textures. You can only have 1 enabled at a time. You can have 6 in the scene, but only 1 can be on at once. If it sounds like I'm skipping over a lot, it's because I am. This whole thing was a massive pain in the arse, and to explain the whole thing would be very boring and would take about the length of this whole video again, so I'm not going to do that. But if I show you the whole effect with every element of it separated out, I think you'll see what's going on. And now at long last, let's bring it all together, new and improved, for your viewing pleasure. Just to give a little update on the map as a whole, according to our last trailer and according to our hopes and dreams, we did hope to have this map out by this year, by the end of this year. It's now quite close to the end of this year, and by the looks of things, that's not going to be possible. Of course, this is a piece of fan art, this is something we're doing on our spare time. As a result, delays like that are to be expected, they're somewhat unavoidable. We are still committed to finishing the project, we are still committed to making it as good as it can be, but in all likelihood, we will be releasing it next year. The other thing to know is that we will probably be releasing it in parts. That's partly for technical reasons, because the map is very big, it's better to portion that out. It's partly for pacing reasons, for the story we want to tell. And it's also so that you can play the map as soon as possible, even if you haven't quite finished it yet. So I'm really sorry for the delay there, I'm really sorry for anyone who was really excited to play it this year, but just know it's still happening, we're still working on it, it's going to be really good fun, we're really proud of it, and we can't wait to share it with you.